What are the alternatives to CFCs? Have you ever wondered what happens when harmful substances like chlorofluorocarbons are phased out? Today, we will discuss the alternatives to chlorofluorocarbons in the context of Antarctic ozone monitoring equipment and polar research technologies. Chlorofluorocarbons, or CFCs, have been found to significantly harm the ozone layer, especially over the Antarctic region. This is crucial for polar research and environmental monitoring. As a result, scientists have sought alternatives that balance safety, cost, and environmental impact. One of the main alternatives is hydrochlorofluorocarbons, often referred to as HCFCs. These compounds contain hydrogen, chlorine, fluorine, and carbon. They have a shorter atmospheric lifespan compared to CFCs because the hydrogen reacts with hydroxyl radicals in the lower atmosphere. A common example is HCFC22, which has been used in refrigeration and air conditioning since the 1970s. However, HCFCs still contain chlorine, which means they can still contribute to ozone depletion, albeit at a lower level than CFCs. The Montreal Protocol has set a timeline to phase out HCFCs by the years 2030 to 2040 to further protect the ozone layer. Another alternative is hydrofluorocarbons, commonly known as HFCs. These do not contain chlorine or bromine, so they do not directly harm stratospheric ozone. HFCs are widely used in refrigeration, air conditioning, and foam blowing. While they have shorter atmospheric lifetimes, they are potent greenhouse gases that contribute to climate change. HFC 130 is a well-known example, often found in vehicle air conditioners. Due to their climate impact, some HFCs are being phased down in favor of newer compounds with lower global warming potential. Beyond these, there are other alternatives worth mentioning. Hydrocarbons such as pentanes, carbon dioxide, and water are being used in refrigeration and foam manufacturing. For instance, phenolic foams and extruded polystyrene products now utilize hydrocarbons or injected carbon dioxide instead of CFCs. Carbon dioxide and water are seen as promising long-term alternatives due to their minimal environmental impact. In the polar regions, where monitoring the ozone layer is essential, the transition from CFCs to these alternatives has played a significant role in slowing ozone depletion over Antarctica. However, some substitutes, particularly HFCs, present challenges due to their greenhouse gas effects, which can influence polar climate conditions. Antarctic ozone monitoring equipment continues to track the presence and effects of both CFCs and their replacements, helping to inform environmental policies and protect the fragile polar environment. To sum it up, the alternatives to chlorofluorocarbons include hydrochlorofluorocarbons, hydrofluorocarbons, hydrocarbons, carbon dioxide, and water-based solutions. Each option has its trade-offs regarding ozone protection and climate impact. The ongoing phase-out of ozone-depleting substances and the adoption of less harmful alternatives are vital for the recovery of the Antarctic ozone layer and the preservation of polar ecosystems.